Morning Year 10, we're going to have a look at recapping some work on converting from hexadecimal to denary. And just the first thing to kind of understand is that reading noughts and ones is really confusing for human beings, so this is just a thing for human beings rather than computers. And the idea is really simple. When you're trying to read binary as a human being, it's so confusing, so we just make it a little easier for ourselves and a bit more human being friendly by saying every 4 bits, remember bit stands for binary digit, either 0 or 1. In decimal, in normal systems, normal number systems, we go 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. They're the digits. But the only digits we're using now are 0 and 1. They're the binary digits or bits. So when we have 4 bits, which is called a nibble, we can have any number from 0 all the way to 15. But the idea is really simple. Every time I have 4 bits, combinations of zeros and ones, I just want to represent it for a human being as just a single character. So number, digit, if you like, so 0, 1, 2, etc. Now we're fine we get all the way to number 9, but after 9 things get a little bit difficult because 10, of course, defeats the object. I just want a single character, so I just use letters. So this is 10 is A, 11 is B, 12 is C, 13 is D, 14 is E, and 15, the biggest number that we can make with 4 bits, is F. So that's what we're going to do. It's not a bad idea in the exam just to jot down A is 10, B is 11, etc. Anyway, let's have a look what you're doing today. There's not an awful lot to do, just going to keep on top of a few things. So please have a go at all these questions. I've done the first one for you, but we're going to have a look at question 2 now together. And it says convert BC to denary. So the idea is that B actually represents 4 bits. And if we think about what B is, A is 10, so B must have been 11. So we'll put that in, that's 8. I can't have any 4s. I can have a 2, that takes me to 10 and 11. And then the C part was just a shorthand for writing 12. So that would be an 8 and a 4, but the rest are just zeros. So that's it. The quick method of doing it, there's 2 methods, but the quick method is just a sort of brute force method. Just write them, each of those things, as 4 bits, and then you've got it in binary. The only thing is when it comes to converting from binary to denary, we haven't got the correct units. So just write it out, the correct units, if you like. So I'm just going to write them out again. Here's our B part of it. There was B. When you start to get familiar with this, you can do it really quickly, actually, a lot quicker than filling out this table. And then we got 2 1s, another 1 and a 1. So I'm just working on the C part now. 0, 0. So I've just copied it out again. I haven't really had to do any thinking. I'm just copying those 4 bits, which we've got there, that nibble, and then the next 4 bits, that nibble there. So it's all in the right place. Now then, just a bit of exam technique here. When you're asked to do some working on this, converting from binary to denary, you've got to show your working. So I've got 1 to 8. So I'll put that in, 1 to 8. And then I'm adding 32, and I'm also adding 16. I'm adding 8 and adding 4. And that's it. As you're working, and that should give you, take your time over this, don't make mistakes, so that should give you 188. So you've converted from hexadecimal to denary. So it's really worth just sort of a quick little discussion about this, that the idea behind hexadecimal is that it's easier for human beings to understand. Just want to come back to that. That's something that they often test you on, what's the point of it, because it's not useful for computers. But there are times when we need to copy down numbers, or we might have to tell somebody a number. It could be, for instance, the MAC address of a network interface card. And we might need to talk about that over the telephone or write it down. And if it was all zeros and ones, it would be almost impossible to recite or to remember or to copy out accurately. So you're much less likely to make mistakes in either copying large binary numbers or that sort of thing. So it's just for human beings. It makes it so much easier for us to use.